Modern aviation relies on advanced sensor suites to maintain situational awareness in any environment.
The mechanical systems are inspected rigorously to ensure reliability during operations.
Ground crews work in unison to prepare the aircraft's payload for the upcoming training exercise.
Precision handling is mandatory when transporting munitions to the hardpoints.
The loading process requires exact alignment to ensure the systems interface correctly.
Every connection is double-checked. Safety is the primary priority on the flight line.
Technicians ensure the payload is secure before the aircraft is cleared for takeoff.
Standard operating procedures are repeated flawlessly to maintain high readiness levels.
In addition to precision missiles, the aircraft is equipped to carry unguided area effect rockets.
Different airframes utilize similar logistics chains to remain mission ready. Each rocket is manually inserted and locked into the launcher assembly.
Pre-flight inspections cover every inch of the fuselage to guarantee structural integrity.
The ammunition handling system is designed for rapid reloading during ground turns.
Once the magazine is full, the system is sealed and checked for feed path obstructions.
Regardless of the platform, the principles of safe ammunition handling remain constant.
Interior crews manage their own ammunition supplies to keep door-mounted systems operational.
Modern aircraft are a dense mix of mechanical power and delicate electronic controls.
Blue-tip training rounds allow crews to practice live fire drills safely.
With the payload loaded, the area is cleared for engine start procedures.
A final visual confirmation ensures that all munitions are secure before the rotors turn.
From the air, the crew maintains a constant visual scan of the terrain below.
Crew chiefs are responsible for the operation and maintenance of defensive weapons systems.
Overwater training presents unique challenges for navigation and target acquisition.
The mission concludes as the flight formation returns to the tarmac for debriefing.
Specialized munitions are transported in reinforced crates to protect them until deployment.
The modular design allows crews to configure rockets with different warheads for specific mission profiles.
Each rocket must be seated firmly to engage the firing contacts within the pod.
Electrical connections are established to allow the flight computer to select and fire specific tubes.
High-capacity magazines ensure the aircraft can sustain engagement during prolonged training sorties.
Automated loading systems reduce the time required to rearm the aircraft between flights.
Different airframes utilize unique intake designs, though the ammunition remains standardized.
Securing the avionics bays is a critical step before the engines can be started. Safety pins are removed only when the aircraft is fully prepared for the mission. Once the flight line is clear, the pilots begin their pre-flight checklists.
Twin turboshaft engines provide the immense power needed to lift the fully loaded aircraft.
The aircraft taxis to the staging point, awaiting clearance from the control tower.
With a surge of power, the helicopter transitions from the ground to controlled flight.
Formation
formation flying requires constant communication and situational awareness. Crew chiefs maintain a 360-degree watch, serving as the eyes of the aircraft.
Pilots learn to navigate complex terrain, using natural features for concealment.
Defensive weapon systems are kept ready for immediate response to threats.
Low-level flight profiles are used to minimize exposure to detection.
Flight crews operate in high noise, high wind environments, requiring specialized protective gear.
Agile maneuvering allows the aircraft to change direction rapidly in combat zones.
Managing ammunition feed is constant work to prevent jams during operation.
Training environments vary, from deserts to coastlines, to prepare for global deployment. Pilots use their shadow as a visual reference to judge altitude and speed.
Heavier caliber weapons provide extended range and stopping power.
Clear communication between the flight deck and the cabin is essential for safety.
Hovering over water requires precise control to maintain a safe altitude without visual references.
Weapons are charged and readied only when the aircraft enters the designated fire zone.
Gunners practice tracking moving targets while the aircraft is in motion. Live fire exercises validate the crew's ability to engage targets accurately.
Visual feedback from the impact zone allows the gunner to adjust their aim.
Tracer rounds provide immediate visual reference for ballistic trajectory. Speed and efficiency in reloading are critical to maintaining suppressive fire.
The primary cannon delivers precision fire against light armored targets.
Rocket systems provide area suppression capability for the aircrew.
Accurate delivery of ordnance confirms the calibration of the targeting systems.
Crews must remain proficient in all lighting conditions, from midday to dusk.
The ammunition links are designed to separate cleanly to prevent jamming.
The pilot maneuvers the aircraft to optimize the gunner's field of fire.
Spent casings are ejected clear of the aircraft to avoid interference with flight controls.
Immediate action drills are practiced to clear malfunctions instinctively.
Upon completion of the overwater segment, the flight returns to overland navigation.
Weapons are cleared and secured before the aircraft enters controlled airspace.
Scattered elements regroup into a standard flight formation for the return trip.
Visual approach procedures are initiated as the airfield comes into view.
The aircraft transitions from aerodynamic flight to a hover for landing.
A smooth touchdown minimizes stress on the airframe after a long sortie.
Ground taxi procedures require careful attention to wingtip clearance.
Ground crews marshal the aircraft into its designated parking bay.
Systems are powered down systematically to prevent thermal shock to the engines.
The rotor brake is applied to stop the blade safely.
After hours in the cockpit, the aircrew exits for the debriefing.
Post-flight inspections identify any maintenance issues that arose during the mission.
Weapon systems are safed and inspected immediately upon return.
Flight data is downloaded for analysis and training review.
As the sun sets, the maintenance crews begin their night shift.
Aviation operations continue around the clock to ensure readiness.
Detailed maintenance is the backbone of aviation safety.
Protective covers shield sensitive sensors from dust and moisture.
The fleet stands ready, prepared for the next day's training schedule.